Okay, let me discuss another very useful technique to solve integral. So that's basically integration by substitution or change of variables. Okay. Now this is also something which is actually going to follow straight from the chain rule, okay, of the derivatives. Okay, so you can imagine that there is some function capital F of u. Okay, fine, and u is, let's say, g of x. Okay, and let's say small f is nothing but the derivative of capital F. Okay, so small f of u is actually f prime u. Okay, so I mean, just these are the notations. Okay, so we'll keep these things in mind, and then what I'm going to do is this. Can I write it like this? Capital F of u is actually capital F of g of x. Can I write it like this? Because u is g of x, so obviously I can write it like this. Yes or no? Okay, now let me take the derivative both sides with respect to x. Okay, let's take the derivative both sides with respect to x. These are exactly the same terms, so obviously the derivative will be the same. So what am I going to get? F prime u. What is f prime u? Is a small f of u, right? So f of u into du by dx. Okay, so I've just applied the chain rule on the left hand side. Now I'm going to apply the chain rule on the right hand side, and I'm going to get small f of g of x into g prime x. Yes or no? Is that okay? Now let me do one thing. Let me write it in this way. It's just another way of writing the same thing. I'm just taking the dx on the right hand side, and now let's do the integral both sides. Okay, and that's exactly what you have here. So basically, you are given some function like this. Okay, you are given some function like this, and then you can reduce it to this particular integral by substituting gx as u. So this is your substitution step. I mean, that's basically the methodology that you follow. We'll do one example. I think that's just going to be clear. Okay, yeah, so basically this is the chain rule for the derivative, and because you're going to get the same function on both left hand side and right hand side, so their integral will be the same. That is all that we have written. Okay, is that clear to everyone? Okay, now let's do this step. Let's try and see how do you do this substitution step to find the integral. Okay, so suppose you have to integrate 2x e to the power x squared dx. Suppose you want to integrate this. Okay, now if you see, if I can just take this x squared, call that u. Okay, take this x squared, call that u. So that's the substitution step. Okay, u is x squared. So what is du? 2x dx, right? Basically that's exactly what we have done here. Okay, fine. Okay, now all that you're going to do is take this 2x dx, replace this by du. Okay, so this term is gone. The only term that is left is e to the power x squared, and that can be written as, because u is x squared, can be written as e to the power u. So basically, this is exactly what we have done. We had a term which was like right hand side. We were given a problem where we had right hand side, and we converted it into a problem, like the one that is there on the left hand side, which is easier to handle. Is that fine? So this is also a trick, okay, or a technique through which you can actually solve the integration problems. Is that fine? Okay, And now this is actually easy, right? It is e to the power u. Now plus a constant, of course. Okay, now just be a little careful, when you are going to write your answer. Okay, don't give me e to the power u plus c, because if you see, I gave you this particular function. U is something that you brought in yourself. I gave you this particular function, so your answer should be in terms of x. So what should I write here? Very good. Okay, so that's it. And now if you want to check your answer, what should you do? Exactly, take the derivative of this. Just going to take half a minute. Take the derivative of this, see if you're getting this or not. Okay, because sometimes errors can happen. Okay, and this is a way to check your errors. Okay,